Example number 2, you'll notice I've already drawn a diagram. We're dealing with a soccer ball going down a field. I know the angle it starts at, and I know the velocity, but the velocity isn't horizontal or vertical, it's a little bit of both. So the first thing I'm going to do is find my vertical information and my horizontal. And in this case, it's not as clear cut. I'm going to have to use sine and cos to find my velocities, but that's not too bad because you'll notice I know the hypotenuse. Right now, remember, this is only true the first microsecond it starts. Once it starts going, that vertical will change, the horizontal stays the same. But it allows me to calculate what it starts at, what the beginning velocities are. You will notice the vertical is across from the angle, which means to find the vertical velocity, I need to use sine. So the vertical velocity, or v1 in this case, because it's the starting velocity, is going to be 11.5 times the sine of 30 degrees. So there we go. And then the horizontal, you'll notice, is beside or cozy with the angle, which is the hint that for it, I'm going to use cos, so 11.5 times the cos of 30 degrees. So I'm going to put these in my calculator and get values for them. Now, remember, we're talking about Pythagorean theorem in a sense here, right? So a lot of people are tempted when they find this first one, or my vertical one, they think, oh, I can just subtract it from 11.5. You can't do that because this is triangular math, and triangular math does not work that way. I'm going to find my horizontal, and 11.5 times the cos of 30. There we go. So I got 9.96. Now I know the 30 degrees is only 2 sig figs, but I'm keeping that extra digit because this is not a final answer. I'm allowed to keep extra digits, and actually I should be encouraged to because it keeps the accuracy as we go along. Now I'm going to find my time up because it asks me, my final answer is to find out this distance, but I can't find this distance, which is going to be the horizontal distance, without finding the time first. I just can't. So I know this is true vertically, and then I'm going to find out the rest of the information. I know if I look at this, it's going to go up, and when this 5.75 is true, it's going to start slowing down, which means vertically acceleration is negative 9.8. This is very important that I get this negative, otherwise I will get a weird negative time, which is not possible. Now I have to think of a third piece of information vertically. I know that horizontally I can't do anything because I don't know that distance and I don't know the time. And the only equation I have over here is v equals d over t. That's the only one that's available to me. So I need to use it. I can't use it yet. Here, though, I have more options because I have the kinematic equations. And if I think about this, there's a couple ways of doing it, but I'm going to consider what happens at the halfway point. Here, at the halfway point, I know it stops going up and starts coming down. So I'm going to calculate the time up, because if I consider the time up, then I know V2 vertically is going to be 0 because it stops going up and starts coming down when this happens. So if I can find the time up, in this case, the time up is going to be the same as the time down. So I find the time up, I double it, and find the time down. So all I need to do is pick the right equation, solve for time, double it, and I'll be good. I'm going to stop there just because I'll run out of time on this video. Please join the next video to see this equation being solved.